Hi class, we're going to look at this PowerPoint to talk about analyzing data and how it applies to homeostasis. So this first graph we're going to look at before you answer the questions are the axes at first. So on the x-axis here on the bottom we have time, and on the y-axis we have the body temperature. What I want you to pay attention to is when it rises and falls. So this is over minutes. So how is the body temperature changing over time? And then look at the starting temperature and the initial peak to the final temperature and this bottom peak. What we're going to do is pause this in a moment and answer the questions. What do you notice from the graph? So how can you describe what's happening here? And then how does your body respond when your temperature gets too high? So what's happening at these peaks when the body is getting hot that makes it go to this bottom and drop there. So pause here and answer those questions. After you've paused, you should now be seeing this slide. So now when you look at this slide, you're going to see more information on the graph. It's the same graph, it just now has more information. So what we've added on is this blue dotted line. That's going to be our equilibrium or our base temperature that the body is trying to get back to every time. So it's about 37 degrees Celsius. The red arrows are pointing at the peaks when we go above 37 degrees Celsius. And it's saying when I go above, the body temperature is too high, I increase the sweating and the vasodilation in the skin. So my blood vessels are getting larger. I'm going to see my skin getting red because I'm trying to bring blood to the surface of the skin so that the air can cool it down. Evaporation is also going to cool it down. So when I sweat and I have liquid on the skin, when it evaporates, it's going to cool down. So when I go above, that's what's going to happen to try to bring it back down to the blue 37. Now my blue arrows that are pointing up are showing me my body temperature is too low. So now I've gone past the equilibrium because I'm sweating. So I'm going to stop sweating and I'm going to stop vasodilation in the skin. My skin's going to return to the normal color and my body temperature is going to rise again. If it goes past the 37, I restart the cycle and my body temperature is high and I start sweating again. So now in a moment you're going to pause and answer these two questions. What is the purpose of sweating? And then how does your body respond when the temperature is too low? So pause now and answer those questions. Now we have a new graph. So when you go back to your slide, you can see this new graph. On this graph, my time is now in hours. My y-axis is still body temperature. So what's happening here is I have this graph in the left that's very similar to the graphs we were just looking at, but squished and zoomed out. And then it says cells are infected with a pathogen which will release chemicals that trigger the set point to increase. So all of a sudden I go from 37 as my normal and I jump up to this 40 as my normal. So I want you to describe what is happening in the graph and how you think the body will respond. So pause now and do that. After answering those questions, you might have gone on to this slide, and you're going to see that the body responds with shivering and vasoconstriction. So all of a sudden, my body feels very cold. I'm going to shiver, my blood vessels are going to go in, I'm protecting the internal organs, my skin might kind of look more of a whitish, paler tint to it. Up here at this new set point of 40, it's going to maintain its increased temperature, so I want my body to be warmer because that's where it's fighting off the infection. So how is this example here different than here where I'm going back up and down to maintain at the same point? Oops. Pause there and answer the question. So here we have our definition of homeostasis. So homeostasis is one of the fundamental characteristics of living things. It refers to the maintenance of the internal environment within tolerable limits. For example, all sorts of factors affect the sustainability of our body fluids to sustain life. These include properties such as temperature, salinity, acidity, and the concentration of nutrients and wastes. Because these properties affect the chemical reactions that keep us alive, we have built-in physiological mechanisms to maintain them at a desirable level. What this means is, in your body you have many levels of homeostasis. Blood sugar, temperature, body fluids, anything in your body is in a homeostasis. It wants to be within a certain range. Depending on what it is, the range may be bigger or smaller, but you have things built in so that if you go outside of the range, your body is going to react to bring you back to the range. When we're just looking at temperature, we'll look at other ones later on. Another vocab that we're talking about a lot is going to be feedback. So when a change occurs in the body, there are two general ways that the body can respond. In negative feedback, the body responds by stopping or reversing the direction of the change, because this tends to keep things constant and allows us to maintain homeostasis. Most homeostasis is going to be maintained through negative feedback, because if I go up in temperature, my body's going to do something and then go back down. I'm going to maintain level. On the other hand, positive feedback is also possible. This means that if a change occurs in some variable, the response to that change is going to keep going in that same direction. This has a destabilizing effect. It does not result in homeostasis. Positive feedback is used in certain situations when relatively rapid change is desirable. So if we look back at our examples, this is positive feedback, because all of a sudden I'm increasing the change. I want my body to increase in temperature because that's where I fight off the infection better. If I look at here, I want to keep going back to that 37 degrees. And this is negative feedback because I want to keep going back to that same temperature. Here's an example of both positive and negative feedback as it relates to climate change, which is what we talked about last year. So if I have global warming and it's going to create a change that slows down the warming, it's negative feedback because it's making the change happen slower. However, if I make a change that makes it happen faster, such as melting ice caps and increasing the absorption of energy, I'm going to speed up the warming and it's going to happen faster and faster and faster. Here's an example with our bodies. So these are both going to be negative feedback examples. If my body temperature increases, I'm going to sweat, which is going to decrease my body temperature. If I decrease my body temperature too much, I'm going to shiver, which is going to increase my body temperature. So I'm going to do these things to maintain a stable temperature. Thank you, and you're all set for class.